Welcome to the HiRSE Summer of AI for RSE. If you want to learn more on how AI is changing the way we write and work with research software, this collection of episodes is for you.
Hi everyone and welcome to this video. My name is Stephan Druskat and I will discuss some higher level aspects of what the advent of generative and agentic AI may mean for the role of the research software engineer, the RSE, and for our practice going forward. First up, let me quickly introduce myself. I'm currently a research software engineering researcher at TU Braunschweig, and in the past I've worked as an RSE in linguistics, in digital humanities research projects for around about 10 years. And I've had a growing interest in what happens to the software that I would write in these roles after the projects ended, so research software sustainability. I subsequently got involved in the international research software sustainability community. I've become a fellow of the British Software Sustainability Institute in 2018. And in the same year, I have co-founded the RSE, which is the German Society for Research Software. And I've served on the board for a few years there as well. Over the years, I've grown an interest in research software metadata, in fair software publication and in software citation. And I've created the citation file format to make it easier for RSEs and for developers to make their software citable and for researchers to find the correct and complete metadata they need to cite the software they use. Other research interests of mine include research software architecture and supply chains, understanding research software ecosystems at scale, using mostly quantitative data from repository mining there, and increasingly also software security and the interplay of RSE methods and AI. And since June of this year, I have worked as a research software engineering researcher in a project that caters for many of these interests and that people familiar with the Helmholtz infrastructure project HiRSE may find interesting because it has a similar structure. The project is called Digital Science Support Space Lower Saxony, or short DS3, and we aim to build digital research capacity for many universities and colleges in Lower Saxony in the fields of research software engineering, but also high-performance computing and AI. The project runs for 5 years and it provides new HPC infrastructure and cross-institutional support in all of these fields, the latter through 6 different science support teams at universities in Braunschweig, Clausthal, Hanover, Göttingen, Osnabrück and Oldenburg. And additionally, we have 8 local contact points at other universities and colleges as well. The support teams develop software and consult on research software engineering. We also run trainings and workshops around research software engineering, HPC and AI. And finally, before I begin, I'd like to thank the HiRSE team and Claire Wyatt for the invitation to contribute to the HiRSE Summer of AI in RSE. What I'll talk about today is some general thoughts on what the advent of generative and agentic AI means for the RSE role and how our practices may change, but also what we as RSEs need to be able to realize these changes in new practices and how we ourselves can support a vision for what responsible use of AI means for research software engineering. I don't know about you, but my own experience just from having had conversations over coffee, for example, during breaks at different research software conferences or events over the last months, is that AI and the question how to deal with it as RSEs currently really dominates a considerable part of the discussion within the RSE community. If you take this individual experience and combine it with a number of news items that deal with AI, both positive and negative, across all the different venues from public broadcasters to kind of specialist magazines and social media, and if you look at the number of preprints and publications that present AI-related work, you get the feeling that AI is everywhere and about to take over everything as well. And that's not just a gut feeling. To get an exemplary and a very superficial first glimpse into data that supports this feeling, I had a quick look at 2 indicators. On the left, what you see is the number of commits on GitHub that have been made using the agentic AI tool Claude Code. And these commits have been identified using fuzzy string search on the commit messages and matching against occurrences of some specific strings that would indicate that the commit has been made by the tool or that the commit has been made by the user after using the tool Claude Code to generate code. These data are from a website that tracks these commits called claudescode.dev. And the other on the right is the number of contributions to the largest international conference in software engineering, ICSE, that are AI related. Here I looked only at accepted publications in the main conference tracks that have existed since 2018, and then I've categorized them as related or unrelated to AI, purely on the occurrence of a number of keywords that are clearly related to AI in the contribution title. Now, keeping in mind that this is a very coarse indicator to begin with, and that this analysis will have missed many more AI-related titles in some tracks or workshops that are dedicated to the use of AI in software engineering, this still shows that AI-related content has increased to make up over a third in this year's edition of HiRSE. Now, a common understanding among software engineering researchers about how AI will generally change the practice of software engineering is that the future of software engineering will include a shift away from methods for code creation and software design towards the verification of increasingly AI-designed and AI-implemented software. In other words, where software engineering has extended programming to create a comprehensive paradigm for software-related activities, some of these activities may now move into the background while others may receive more focused attention. For example, the assurance of quality, dependability of the software, security, and sustainability. In short, and again a bit simplified, software engineering is moving up a level of abstraction. Instead of spending time on implementation, the use of AI likely shifts software engineering activities towards natural language specification and then reviewing AI-generated implementation and deciding finally whether the implementations are correct and suitable. Now finally to the research software domain. For domain researchers who have no programming experience and have previously not been able to create their own code for their own research, this development is actually great news, right? Domain researchers have the relevant knowledge in their domain and can express exactly what they want their code to do, or what novel method they would like to implement as a prototype, for example. And now, with generative AI, they can use chatbots or they can use agents to produce the code for them without having to learn a programming language first. This means that they can automate analyses, build prototypes, and explore research ideas much faster than before. So the barrier to creating code has basically fallen. And now that the researchers can produce their own code using AI, the question becomes, what does this mean for the RSE role? Will generative and agentic AI make RSEs redundant? And this isn't just a rhetorical question. Even today, we've had reports from RSE leaders that they are under increasing pressure to justify why they need to hire new RSEs, or even why they need to retain their current RSEs if they could, quote, just replace them with AI, unquote. So in the next few slides, I'm reporting some previous work that we started in March of this year in Edinburgh during a workshop by the Research Software Alliance called Research Software Engineering in the Age of Generative AI, Building a Community Vision. The workshop brought together RSE leaders and experts from around the world, and myself, with the aim to develop a community vision for research software engineering with generative AI, to create a roadmap to identify opportunities, identify risks and good practices, and prioritize concrete community actions. And there are quite a few outputs from this, including the workshop report, the draft of the community vision document itself. There's a list of resources related to the workshop topic, and I can really only recommend that you have a look at these to get a clearer picture of what the workshop was about and where the journey is going. And also there is this blog post, Research Software Engineering in the Age of Gen AI, Same Value, Changing a Practice, that I've co-authored with Michelle Barker, Ian Cosden, Quinlang Yang, Rob Haynes, Dan Katz, Joe Shingleton, and Ben van Werkhoven. And in this blog post, we discuss how we think generative and agentic AI will impact the RSE role. And a strong motivation for writing it was actually the pressure that the perceived possibilities of Gen AI do place on RSE groups, when researchers can now use AI tools to generate research code. And in fact, the fear that AI will negatively impact RSE groups isn't completely unfounded, because this is exactly what we've seen happen in industry just a few months ago, where a lot of tech companies, but also other companies in the productive industries, have made employees redundant in their thousands, many as part of a strategy to focus more on AI-related technologies. So following from just that, the answer must surely be yes, AI will make RSEs redundant because AI is already making software engineers redundant. Or does it? The previous slide, of course, didn't show the whole picture, because what we've seen since the redundancies across industries as companies, quote, pivoted to AI, unquote, is, for one, a wave of rehirings, many of them done a lot more quietly than the original letting go of staff. In many cases, humans were rehired because it turned out that AI couldn't do the job as well as originally thought, as well as humans, or, to quote the first snippet here, artificial intelligence and automated systems failed to deliver the desired quality level. Secondly, companies that provide models and AI tooling are now trying to finally get some return on the quite huge investments they've made in creating their products, a lot of which was borrowed money, and they're now adapting their pricing structures. So the result is that companies using these products now realize that this usage is becoming really expensive and that they won't be able to keep using them with the intensity they originally planned for. And all of a sudden, you can see that the picture is a lot less clear, at least for the moment. This all the more if you look more closely at the productivity gains that the use of AI actually promises and what the reality is. Because recent studies on productivity gains and skill enhancement show that LLM chatbots and the use of agentic AI frameworks benefit less experienced software developers more and experts less, at least when it comes to productivity. And importantly, they also do this only in the short term. But studies also show that the use of AI does not result in improved software engineering skills for the less experienced developers. Instead, if AI is taken away from this group after a while, the productivity of this group drops significantly and does not recover. And experts, on the other hand, have shown smaller productivity gains, but these gains have been stable and sustained. And also, the studies showed a much more critical and selective use of AI tools by these expert developers and more distrust of the results that AI tools produced. And I think the latter result especially is crucial, as the studies also showed a negative correlation between throughput, so the amount of code that's been produced, and code quality. And that means that technical debt accumulates over periods where you have sustained use of generative AI tools. And there's one study that says that specific agentic frameworks, for example, produced 30% increases in static analysis warnings and 41% increases in code complexity. And also, and that's important, the degree to which quality degradation happens depends on the application of suitable quality assurance measures within projects. For example, automated code analysis and quality assurance workflows that focus quality and maintainability. All in all, the studies and the results show that software engineering expertise is a fundamental factor for sustainable productivity gains in the first place, but also that critical and selective use of AI and expertise in validation and verification and quality control, these are things that are crucial for the creation of maintainable high-quality software. So basically, without previous software engineering expertise, productivity gains through the use of Gen AI are transient, while technical debt and unmaintainability, but also a specific or certain cognitive disconnect between the code base and its creators threaten the sustainability and the quality of the software that's being created. Perhaps summarizing in one sentence, creating more software more easily does not mean creating better software. And I think it seems clear from these results that the software engineering expertise that RSEs have will be crucial in handling generative AI for research software development, and also that RSEs are in a very good place to guide AI adoption by others in research. But software engineering expertise isn't the only factor here. So let's have a look at the reasons why RSEs existed in the first place. Research software engineers have never been valuable to the research simply because they know programming languages. The value of research software engineering comes from combining software engineering expertise with an intimate understanding of research and the research environment. RSEs not only create or maintain software, they help make research software with all its specific and unique requirements reliable, reproducible, maintainable, and sustainable. To say it another way, RSEs bridge the worlds of research and software engineering. And now what happens when Gen AI enters the picture? In a situation where we have researchers who use agentic coding tools without sufficient expertise and experience to write increasingly complex software, There is a threat of over-reliance on the AI tools, of researchers depending on AI. And that can generate a significant disconnect between the research and the code base. So if an AI-generated code base cannot be sufficiently understood and verified, and the quality cannot be assured with confidence, this can lead to unintended errors and inaccuracies. And this is dangerous for research software in particular, because errors and inaccuracies threaten the robustness of the respective scientific outputs of the software, of the research, and of the research results themselves. So in this situation, RSEs are well positioned to remove this disconnect between coders and code, because based on their existing knowledge and expertise, not only in software engineering, but also in the context in which research software is developed, they understand if code can be trusted, if it is computationally but also scientifically correct, if it does the right thing, and also if it does the right thing in the right way. And that's why we believe that RSEs will be critical in assessing not only if research software uses the algorithms best suited to process the specific research data, but also if it implements a research method as intended. And finally, they can ensure that the research software, and therefore the research itself, is reproducible, and if the software is reusable, maintainable, and sustainable. So rather than AI making RSEs redundant because code can now be produced by everyone, it makes RSEs actually more important because it increases the importance of verification and critical evaluation. Because RSEs understand research and software engineering, they can frame problems more precisely, they can more effectively evaluate trade-offs and verify internal correctness and consistency, and they can address the long-standing challenges in research software which they've been intimately familiar with already. So with AI, RSE skills become especially important for using natural language interfaces that AI usually provides to produce optimal results and to verify the results that AI produces and that they are produced in controlled workflows that are based on software engineering expertise. So in conclusion, as authors of the blog post, we firmly believe that the partnership between researchers and RSEs is still absolutely needed, even if the practice of research software engineering changes with generative and agentic AI. And this is the first and perhaps the main point of my presentation. And in fact, this doesn't seem to be just wishful thinking, as I've recently seen initial research that actually provides evidence to fully support this point, and which I hope will be published in due time. But I'd also like to go forward a bit. So beyond the realization that the practice of RSEs may change, but that the value and the value proposition of RSEs to research, to the partnership of researchers and RSEs will stay the same, I would like to look at some other things that we as RSEs must consider when we go forward. And some things also that must be in place to ensure that we as RSEs can fulfill the potential in the age of generative and agentic AI. And also, finally, that RSEs are enabled to make responsible use of AI and continue to ensure the trustworthiness and quality of research software. First of all, I think it's crucial that we as RSEs accept that AI is likely here to stay, at least for the time being, and that we understand that it will affect our work in some way. Because it is a fact that with modern AI tools, researchers can produce code, and they will produce code. And this does already affect the practice of RSEs. There is some anecdotal evidence that the queries that some RSE groups receive from researchers they work with now focus less on programming basics and more on higher level design aspects of research software, for example. And in this situation, we cannot put our head in the sand and try to ignore that AI is increasingly being used in the research software space. So instead, we must prepare and we must maintain our skills in the relevant areas, and this of course includes that we should understand how Gen AI, how agentic AI frameworks work, for the areas at least that are relevant to our work. And as our work changes through the application of AI, it's important that we also strengthen our skills in areas such as specification, verification, validation, quality control, and software security, which are core software engineering skills. I personally believe that knowing Gen AI is important, even if you fundamentally oppose it, or if you oppose the way it's produced, if you oppose the way it's pushed. and if you would be happy to not have to go near it with a 10-foot pole. If you do oppose it, I think it may be helpful to think of it as a way to know your enemy and a way to strengthen your arguments against it. So know your Gen AI, know your agentic AI. And this also leads to a second premise. Because I believe that it's important to refrain from judging other RSEs, other researchers, or perhaps generally other people for the attitudes and the practices around AI, as long as they act within the constraints of good scientific practice. What this means is that do not assume that just because someone uses AI, they are in line with any strategy pushed by Silicon Valley tech bros, or that they condone the clear and well-known negative effects of AI on many aspects of human life and on the planet. I think it's important to keep in mind that there are many reasons why RSEs and why researchers may choose or may feel compelled to use AI. This could be technical curiosity, which I wouldn't put past any RSE, actual improved productivity, the pressure to produce results and publish them, the fear of being left behind, pressure to compete for AI-focused funding, etc. And vice versa, I think it's a good idea to not assume that just because someone chooses not to use AI, they live under a rock. Again, there are many, many good reasons to not use AI, to oppose AI. For example, the ethical effects, the environmental effects, political, financial effects, the threat of de-skilling, security threats, etc. So being tolerant does not mean that we should not engage in discussions or should engage in actions around these topics. It does also not mean that we maintain what some would call neutrality. It simply means that, just like in peer review, we should judge arguments and actions and outcomes and evidence, not people. Importantly, I think being tolerant also does not mean that we should allow ourselves or others to cut corners, especially when it comes to good scientific practice and to good research software engineering practice. And in this respect, nothing really has changed or will change in research software engineering. The important thing is still that we support better research through better software, irrespective of whether we use AI tools or not to get there. And this also leads us directly to the next premise of responsible research software engineering in the age of Gen AI, and that is policies. As research software engineers, we need clear and comprehensive policies and guidelines that clarify the requirements, the constraints, and the practice of the use of AI in research software engineering. And let me refer to some previous work by Caroline Odebrecht at Humboldt-Universität zu Berlin, who argues that such guidelines and policies should be developed with participation of all relevant stakeholders. And this importantly includes RSEs as research software practitioners. It's a very clear principle of all user-centered design, and it can help make sure that the guidelines actually cover the aspects that are important to our work. Of course, even the best guidelines do not enable RSEs to use AI in general and to use it responsibly. This requires infrastructure, and again, linking back to Caro's work, this infrastructure includes both technical infrastructure, meaning the hardware and the software that enables us to make use of AI technologies in the first place, and to use it in accordance with good scientific practice, with local and national laws and regulations, but also with the requirements of the research, for example, in terms of software and data security or cybersecurity more broadly. It also includes human infrastructure, meaning that we need experts for training AI-related skills, and we need curricula that help all relevant parties stay skilled up. But we also do need ethical and legal experts, for example, and many other DRTP roles. And finally, to support responsible research software engineering in the age of Gen AI, we need more RSE research. So research on research software engineering to both develop AI-related methods that target research software specifically and improve AI-based RSE workflows. But also we need more RSE research that provides evidence regarding the usefulness and the effectiveness of Gen AI, of agentic AI in research software engineering. And that helps us understand if and when the application of AI to research software workflows is useful. So in conclusion, generative and agentic AI are clearly changing how research software is created. As a result of this, the role and the practice of RSEs as experts in the engineering of research software is likely to change and is likely to shift from implementation to the higher level engineering tasks of specification and also verification and validation of research software and quality assurance and security. AI is likely to also introduce new challenges, for example, in software security and technical debt. And recent research shows that RSEs, as opposed to novice researchers who use AI to generate code, can benefit from the use of AI methods and gain productivity and capacity if they use the technology critically and selectively. And this also means that their own AI use and the use of AI by their partners in research will actually strengthen and not decrease the value and the importance of RSEs within the research ecosystem. While AI may make it easier to create more software, it's still up to RSEs to make sure that research software remains trustworthy, remains reproducible, maintainable, and sustainable, and that it addresses the unique challenges of software in the research context, and that thus better software can lead to better research. To enable responsible research software engineering in the age of Gen AI, RSEs must accept the increasing use of AI and the challenges it brings, and also be open to a spectrum of attitudes towards AI and to trust evidence rather than prejudice. And RSEs require support through suitable and clear and actionable AI policies and through infrastructure that enables the responsible use of AI in research software engineering. And finally, more RSE research is required to not only provide evidence for if and when AI use improves research software engineering, but also to develop new AI methods that specifically target research software engineering. And with that, thank you for your attention. The images you've seen around the development of the RSE role are free to reuse. They're available on Zenodo. You can also download the slides for this video from the QR code from the link provided here. And these slides include all the references and all the links you need. Also, you can get involved in the discussion, for example, during the upcoming DE/RSE workshops on Gen AI and the collaborations workshop. And we will run a Birds of a Feather session around Gen AI and research software engineering at the International Research Software Conference in Sheffield on the 7th and 8th of September, co-located with RSECon 26. And you're very welcome to join us at this event and discuss the future of the RSE role and of research software engineering in the age of generative and agentic AI. Thank you.
Thank you for watching this episode. Please check out the slides on Zenodo, linked below, and see you next time.